Okay, before we start talking about metric conversions, we got to talk about the different prefixes that you can have. And I have a really cool mnemonic device to help you memorize all these prefixes. So I remember Mighty King Henry doesn't usually drink chocolate milk. And then I remember micro, nano, and pico. So once I've got that phrase down, I know that this is my base. It's my base unit. And then you'll see a pattern as I fill in the numbers. So deca means 10, hecta means 100, kilo means 1,000, and mega means 10 to the 6. So the pattern goes adding a 0 every time. So it goes 1, 2, 3 zeros, and then it starts going by 3s after that, so 6. Now, as I go down, it's the same thing. So 10, 100, 1,000. And then micro is 10 to the 6th. Nano is 10 to the 9th. And then pico is, let me zoom out a little bit. And then pico is 10 to the 12th. So you can see the pattern there as well, too. It goes 10, 100, 1,000, and then so 1, 2, 3 zeros, then 6, then 9, then 12. So I created a little graphic. So let me add that in for you. And we're just going to keep that snapped in this top right-hand corner when we need it. So you can see in the graphic that I have all our prefixes listed, I have their symbols, and then I have the powers of 10 and then what they mean. So we're going to use this to help do our conversions. All right, so let's look at a one-step problem. So why do I call this a one-step problem? I'm only dealing with one prefix. So you see that right here, I have my base unit, but there's no prefix attached to it. But when I look at this part, I have a prefix and my base unit. So I'm only dealing with one prefix. So I only have to do one step. Now let's bring back our prefix chart that we did on the previous slide. So let's put that up there because we're going to use that as reference as we solve this problem. So these are all done the exact same way. You want to start with what's given. So 5.723 grams. And I want to make a conversion. So I want to make a division bar and I want to drop my unit. So I want to put the grams on the bottom so that grams cancels off. So this will cancel off with this. Now on top, I want to put my milligrams. Now for the numbers. So I have this written in a very particular order for a reason. So I have grams, which is my base unit right here, and I have milligrams, which milli is right here. So my base unit is higher on the list. So whoever's higher on the list should get a 1. So since grams is higher, I put a 1 right there. And milli, which we see right here, means 1,000. So next to milli, I want to put 1,000. And that's true because there are 1,000 milligrams in a gram. So you always want to check to make sure that this is a statement of equality before we continue. But if you remember that whatever's higher on the list should get the 1, and the number goes with the other unit, you should be okay. So we do the math, and I get an answer of 5,723 milligrams. I have 4 sig figs in my beginning number, so I need 4 sig figs in my final answer, which I do. So now I want you to take a second and practice this one. Once you give it a shot, come back and I'll go over how to solve it. Okay, so I want to solve this practice problem. So I have 2.54 centimeters, and I want to convert that to meters. So I drop centimeters, and I'm going to go to meters, and I look at my list up here in the top right-hand corner, and centi is right here, and meters is a base unit, which is right here. So meters is still higher, so I put a 1 there, and centi means 100, so I put that there. Now, centimeters will cancel, and when I do the math, I have to take 2.54 divided by 100. Since it's on the bottom, you divide, and I get an answer of 0.0254 meters. My beginning number has 3 sig figs, and my answer has 3 sig figs. These zeros do not count, so I don't start counting sig figs till I get right there. But you do want to continue. You do want to write these zeros out when you're writing the answer. Okay, so this is what I call a two-step problem. Now, why do I call it a two-step problem? Well, I call it a two-step problem because I have one prefix here and I have another prefix. So I'm trying to go from something with a prefix to something with a prefix. So I like to think of this one like baseball. I have to run to first base before I can go to second base. So I'm starting at kilometers, which is right there. And I want to get to millimeters, which is right there. So the easiest way to do this, because all of those numbers written up there deal with the base unit, the easiest way is to go from kilometers to my base unit first, and then go from my base unit to my next prefix. And that'll make it flow a lot easier and make it a lot easier on you thinking about this. So now that we have a game plan, it's done the exact same way as the one we did on the other page. So 0.00345 kilometers. I drop kilometers, and I want to go to meters first. Now, I look at the list, and I see that kilometers is higher than meters, so I want to put my 1 next to kilometers, and I put 1,000 next to meters because that's what kilo means. Kilometers cancel, and I'm still not in my desired unit. I got to get to millimeters, so I need to do another conversion. Meters to millimeters this time. I look at my list. Meters is here. Millimeters is there. So meters is higher, so I put a 1 next to meters, and milli means 1,000. Cancel off meters, and now I can put this in my calculator. So I'm going to take this times 1,000 times 1,000. And I get an answer of 3450 millimeters. I have 3 sig figs given to me at the beginning, so I need 3 sig figs at the end, which I do. This 0 does not count, so that is my final answer. So take a second and give this one a try. Pause the video, and we'll be back in a second, and I'll explain how to solve it. Okay, so now that you've done it, let's give it a shot. So I'm starting with centimeters, and I need to go to nanometers. So I'm starting here, and I need to get here. So here's our game plan. I'm going to go to my base unit, and then I'm going to go to nanometers. It's going to make everything a lot simpler to do this in 2 steps. So I start with my given, 57,032 centimeters. I'm going to drop centimeters, and I'm going to go to meters first. Meters is higher, so I put a 1 there, and centi means 100, so I put it there. I'm getting all of that information from right here. Meters is higher, so it gets a 1, and centi means 100. Still not at nanometers, so I need to do another conversion. So I drop meters, and I'm going to go to nanometers this time. Now, I look at my list, and I have nanometers here and meters there. So meters is higher. Put a 1 next to meters. And then nanometers is 10 to the 9th power. All of my units cancel except nanometers, which is good. and I'm going to put this all in my calculator. So I take 57,032 divided by 100 times 10 to the ninth, and I get 5.7032 times 10 to the 11th nanometers. I have to use scientific notation because the number's so big. If you didn't get times 10 to the 11th, check how you're punching it into your calculator. You might have forgot some parentheses. And I was given 5 sig figs at the beginning, so I need 5 sig figs at the end, so that's why I have that big chunk at the beginning. But that's the correct answer. Okay, so this is a derived unit problem, and I actually have 2 examples to do for you because they are a little bit different from each other. So, how this is written here is a little deceiving. That right there is a division bar. So, let's rewrite that. 25 kilometers per hour. Now, I have to change each one of these units individually, so kilometers is a unit of length, so I have to change that to meters, and I have to change hours, which is a unit of time, to seconds. So we're going to do 1 unit at a time. So I make a conversion bar, and I need kilometers to cancel, so we'll do that first. So kilometers is in the numerator, so I need to put kilometers down here. So I drop my unit kilometers. Now I can go to meters. If I check the list in the top right-hand corner of this screen, kilometers is higher than meters, so I'm going to put a 1 next to kilometer and 1,000 next to meters. Kilometers cancel, and I've converted the first unit. So now I have to take care of this hours part. So we're going to do that in a completely separate conversion over here. So I have a little bit of a problem. Hours is in the denominator. So if I want it to cancel, I can't just put it in the denominator like we've been doing in these previous problems. I have to put hours in the numerator up here to get them to cancel. So hours needs to go up there, and then I can put seconds on the bottom, or you could go minutes and then go from minutes to seconds in another conversion. And I know that there is 3,600 seconds in 1 hour. Hours would cancel, and I get seconds. So now I can get an answer for this problem. So in my calculator, how I'm going to type this in is 25 times 1,000 divided by 3,600. And I get an answer, and I have to round to 2 sig figs, of 6.9. And the units are interesting for this one. I have meters per second. So meters per second. Now let's try the second sample problem because this one is a little bit more difficult. So I have 4 cubic meters here. And I need to change that to cubic centimeters. Now this isn't just like the problems we were doing. You have to pay real close attention. So I start with my 4 cubic meters. And now all of these conversions up here deal with just 1 meter. So 1 base unit. So I can drop meters. I can't drop cubic meters yet. I'm going to show you the long way and then I'll show you the short way. But I can drop meters, and I have to go to centimeters. And I know that there's 100 centimeters in a meter according to this chart up here. And that cancels off 1 of the meters. So that turns that into a 2. So it's sort of like x to the 3rd power divided by x. It turns into x squared. So I have to do that same conversion again. So I have 1 meter on the bottom, 100 centimeters on top. Another meter would cancel. And if I do it a 3rd time, I get rid of all meters, and I'm left with cubic centimeters, because I would have centimeters times centimeters times centimeters. Now the fast way to do this, I'll quickly show you right below it. Let me zoom out a little bit. Okay, so I would start with 4 meters cubed, and I can drop meters cubed, and I can go to centimeters cubed, and I know there's 100 centimeters in a meter, but if my units are cubed, I also have to cube these numbers. So 1 cubed is still 1, so the bottom is still 1, but the top is 100 cubed, so I would have to take 4 times 100 cubed. And I get the answer of to 1 sig fig, 4 times 10 to the 6th cubic centimeters. All right, so practice this one, pause the video, and when you come back, I will go through the answer for you. All right, so for a derived unit problem, I have to rewrite that, so 435 milliliters per second, and I need to change milliliters to liters and seconds to minutes. So pick one, change it, and then pick another one. So let's drop milliliters first, and then we'll go to liters. 1 liter contains 1,000 milliliters, according to the chart in the top right-hand corner. Milliliters cancel. That unit is taken care of. Now I can put seconds on the top to get it to cancel, and I can put minutes on the bottom, and 1 minute contains 60 seconds. So seconds cancel. I get minutes on the bottom, so now I can plug that into my calculator, and I get 435 divided by 1,000 times 60 to get an answer to 3 sig figs of 26.1 liters per minute. All right, this last one is a word problem, so you have to read the question and then pull the information out of it. So if I was traveling at 60 kilometers per hour, so right there, that's something important. So let's underline it. So 60 kilometers per hour. How fast would I be going in nanometers per second? So my given is right there. So let's write that like we've seen the other problems. So 60 kilometers per is a division bar and hours on the bottom. And I want to change that to nanometers per second. So we're going to pick one unit first, since this is derived, fix it, and then we'll do the other. So kilometers will go to the bottom. And this time, let's look at our chart. Right there. I have to go kilometers to meters first. So 1 kilometer contains 1,000 meters, and then I can go meters to nanometers. 1 meter has 10 to the 9th nanometers. Now kilometers cancel, meters cancel, so I've taken care of the first unit. And now hours needs to go on top so I can get it to cancel, and I can put seconds on the bottom, because I know 1 hour is 3,600 seconds. Hours cancel. I've got that unit taken care of, and now I can just plug it into my calculator. So 60 times 1,000 times 10 to the 9th divided by 3,600. And I need to use scientific notation for this, and I'm only allowed 1 sig fig. So the answer would be 2 times 10 to the 10th nanometers. Nanometers per second. Okay, so give this problem a try, and when you get back, I will show you how to solve it. All right, so in this word problem, I have to first dissect what's given to me. So a student is traveling to class at a rate of 5 meters per second. What is their rate in meters per minute? So let's write my given out. So I have 5.00 meters per second given to me, and I need to change that to meters per minute. So actually the meters is already taken care of, so I don't need to convert that at all. I just have to convert the seconds on the bottom. So I can put seconds on top, and I can go to minutes. And I know there's 60 seconds in a minute. So seconds would cancel, and now I just have to take 5 times 60, and I get an answer of 300. Now, I was given 3 significant figures, so those 2 zeros have to count, so I have to add a decimal point after the 300 before I can write my units, just so that I have the correct number of significant figures. So that's 300 meters per minute. Okay, so if you still have questions about unit conversions dealing with these prefixes up here, make sure to ask me when you come to class next time.